Today I'm going to be talking about dot product and cross product, what they are, and how to apply them into questions. The definition of the dot product is the quantity A dot B, which is scalar given as A1 B1 plus A2 B2, where A equals A, A1 A2, and B equals B, B1 B2. Another way we can write this is A dot B equals magnitude of A times magnitude of B multiplied by the cosine of the angle between them. This angle goes from 0 to pi, or 0 to 180 degrees. Now, an important definition of the dot product is that if theta equals pi over 2, which is 90 degrees, then A and B are mutually orthogonal. Now, what this means is that they basically are perpendicular. Now, this definition of mutually orthogonal is important because usually in maths and physics we like to use mutually orthogonal basis, which is where three directions are all perpendicular to each other, and it's the easiest way to describe 3D space. Now, if we do the dot product of one direction with another, let's say E1 dotted with E2, this is equal to 0, and that's because the angle between them is 90, or pi over 2. And if we remember the definition of A dot B, or one of the equations, it is equal to the magnitude of A times magnitude of B multiplied by the cosine of the angle between them. Now, if we have cosine of 90, this equals to 0. So this will get us the two vectors dotted with each other when they're mutually orthogonal equal to 0. Something else important to mention is that E1 dotted with itself is equal to 1. Now this is because the angle is 0, and cos 0 is just 1. This applies for any direction, whether it's E2 dotted with itself and E3 dotted with itself. Or, as you'll see in the future, if I is dotted with I, this will get us 1. Same with J and K directions. Okay, so now we're going to use it in a question. The question says let A equal 3E1 minus 5E2 plus 8E3 and B equal minus 6E1 plus 10E2 minus C E3. We're asked to calculate C given that A and B are orthogonal. Now let's remember what orthogonal means. Orthogonal is when A dot B equals 0. So let's just simply do the dot product of A and B. And that can be written as 3E1 minus 5E2 plus 8E3 dot with minus 6E1 plus 10E2 minus C E3, all equal to 0. Now there's some special rules that we need to just recall from earlier on, and it's that E1 dot E1 equals 0, and then when they're not the same number, then it equals, E1 dot E1 equals 1, and when they're not the same number, it equals 0 at all times. So that means we can basically just focus on the E's that are the same number and multiply only them together. So we'll have E1 multiplied by E1, which equals 1, and then E2 and E2, and E3 and E3. They all come in pairs here. So that will lead to 3 E1, still dotted with minus 6 E1. Then we've got plus minus 5 E2 dotted with 10 E2. And then we've got again plus 8 E3 dotted with minus C E3. and that equals 0. Just stick that on the end. So if e1.e1 equals 1, we can just make it disappear basically. And, oh, not 0, sorry, equals 1. We're just left with 3 times minus 6, which is minus 18. Then we have, again, with the e2 and e2, equals 1. I'm going to put the same for e3 and e3. So for the e2s, we're left with minus 5 times 50, which is minus 50. Get rid of that plus. And then finally, we're left with minus 8c for the e3s. All of that is equal to 0. We'll shift over the natural numbers onto the other side to get 68 equals minus 8c. So that leaves us with c is equal to 8.5, sorry, minus 8.5. Okay, so here we have another question where it says let a equals 3i plus 5j plus 6k and b equals 8i minus 4j. It asks us to calculate the angle between the vectors a and b. Now, as you can see in the top right, I've asked you to recall the equation a dot b equals the magnitude of a times the magnitude of b multiplied by the cosine of the angle between them. So we can do some rearranging of this equation up here to find the angle between them. Simply divide by both the magnitudes of a and b to get that equal to the cosine of the angle, and then finally, oops, that's sine, do the inverse of cosine of the whole thing. So let's get on with that. First step though, we need to do a dot b. So let's write that in full. A dot b equals 3i. As you've probably noticed, we've switched from using e basis to just I, j and k, which usually represent x, y and z direction. Okay, so we've got 3i plus 5j plus 6k dot product with 8i minus 4j. Now to make this a bit easier, we can just put plus 0k, because remember before when we was talking about the e basis and how we could only have e1 dotted with e1 survive, and let's say if we had e1 dotted with e2, it would equal 0. The same principle applies here, where I dot with I now equals 1, and let's say I dotted with j equals 0. So again, we're just looking for the pairs when we're doing the dot product. We see that 3i and 8i are a pair. So we'll do 3i dot with 8i. Then the i's will equal 1. Then we have plus 5j dotted with minus 4j plus 6k dotted with 0k. Again here equals 1, and here again does equal 1. So then we're just left with 3 times 8, which is 24. Then we've got minus 20, because the j's cancel out. Then we've got plus 6 times 0 is 0. So here we've got 24 minus 20, that's just equal to 4. As you've probably noticed by now, doing the dot product of two vectors gives you a scalar in the end. We no longer have direction involved. We don't have I, j or k in this final number, and that is, well, a very nice property of the dot product of two vectors. Okay, but the question asks us to find the angle between these two vectors, and we've just found the dot product of a dot b. Now we have to divide that by the magnitude of a times the magnitude of b. So first let's do the magnitude of a, which just equals the square root of, square root of 3 squared plus 5 squared plus 6 squared, which is 9 plus 25 plus 36. And then we have, that is 34 plus 36, which is 70, square root of 70. We can leave it like that for now. Then we have the magnitude of b, which is 8 squared plus minus 4 squared, and obviously it's plus 0 squared in the z direction or the k direction, but we don't need to put that. So then that gets us 64 plus 16, which is now square root of 80. So let's put a dot b over magnitude a times magnitude b. So a dot b is 4 divided by root 70 times by root 80. That equals the cosine of theta. I'm going to need my calculator for this one. So after doing all of that, we make sure we're in degrees, although the question didn't state it, but let's just say we're in degrees. We'll do the inverse cosine of 4 over root 70 times root 80, and that finally gets us 4 over root 70 times root 80. I guess it's 86.9 degrees. That's a wonky looking 8. There we go. And that is our angle theta, which is between the vectors. Next we have the cross product, which looks like a cross b, as you can see here, which is a vector orthogonal to both a and b, with magnitude equal to the area of the parallelogram with edges a and b. Now I know that might sound confusing at first, so let's draw it out as explained in the definition. If we have vectors a and b, which are already orthogonal, which means perpendicular to each other, let's draw this out. We have two vectors a and b. Then we have an angle here of theta, but we know that this is a right angle. Then it doesn't necessarily have to be a right angle though, but let's say we have a and b which is orthogonal. Then our a cross b will look something like this. A cross b. Now we do this using the right hand rule. So we'll have this will be some art skills. I'm terrible at art. We have our thumb pointing this way. Then we have our first finger, oh my gosh, pointing this way. Whew! And we have our second finger pointing upwards. I want to draw the crease. Oh my gosh, that's wonderful. Look at that explanation. Look at that. I cannot draw, no wonder I do physics. Anyway, so we have our thumb, first finger, and second finger. And this one points in the direction of A cross B. This one is in B, and this one is in A. That's how we will find the direction of A cross B. Now, because our unit basis vectors are mutually orthogonal, we end up with E1 cross E1 equals 0, which is the same as E2 cross E2 and E3 cross E3. It gets a little bit confusing when we want to cross E1 with E2, which equals to E3 now. See how we have a change in direction? This is very, very similar to the A cross B example I just showed you, but that's when we keep the order of the numbers numerical, like on the number line. If we go from 1 to 2 to 3. But if we do the other way around, so 2 crossed with 1, this gets us negative E3. So just remember, if the numbers are ordered correctly, then we are fine. We can leave it as a positive. But if they're the wrong way round, then we are left with a negative direction. This is the same for the others, so I'll write down E3 crossed with E2 equals negative E1, and E3 crossed with E1 equals negative E, oh sorry, this one would be E1 crossed with E3, gives us a negative E2. Because we're not going from 3 back down to 1 again. Let's imagine this number line just going like this, basically. We won't be going from 3 back down to 1. We're going from 1 to 3 here, and we're skipping out 2, which is not allowed. Now, a way we can work out A cross B is either with the matrix method, which I prefer, but you can only really prefer it if you know how to use matrices. And you have E1, E2, E3 on the top row, and then you have vector A on the second row, and then vector B on the third row, like that. And what these straight lines represent is the determinant. So we can just write that as the determinant of A cross B. Another way you can write this is by doing A cross B is equal to A2 B3 minus A3 B2, all in brackets, times by E1. As you can see, this portion has a direction. Then we've got minus A1 B3 minus A3 B1, and that's all multiplied by E2. Then we've got plus A1 B2 minus A2 B1, all of that multiplied by E3, the direction E3. Now, oh, cold. Now what this is really just us A cross B is just finding the determinant of the 3 by 3 matrix, as we have here on screen. As you can see, we've got we have we choose E1, our first element. We go down here into the bottom right and make this as our first block matrix, sorry. Then for the second one, we choose E2, and then we sort of ignore this one and take this as our second block matrix. So ignoring that middle one. But we do a negative for the middle one. Then for the third one, we'll go to the bottom left and make a block matrix there. Okay, now we have a question on the cross product. It says let V equal the vector 5, 3, 2 and W equal the vector 3, 4 and -4. Then calculate V cross W. Now, these vectors are a different way of writing, let's say V equals 5I plus 3J plus 2K. That would be a different way of writing this vector. It's just the same thing, just more compacted form. So this would be, W would be 3I plus 4J minus 4K. Okay, now remembering how to calculate V cross W, we use the matrix version where we stick I, J and K in the top row, and then we write, it would be V1, V2 and V3, and then W1, W2, W3 with the determinant of all of that. So we have I, J, K in the first row, and then second row we have 5 if we're looking at the first term of V, then V2 is 3 and V3 is 2, then W1 is 3, W2 is 4 and W3 is -4. We will find the determinant of that. Now remembering that doing the cross product of two vectors gives us a direction, so we're expecting i's, j's and k's coming out of this calculation. So let's do this determinant. First we use the first element and then do a block matrix of the bottom right elements. So we have the determinant of 3 times -4, put that in the little bracket, minus 2 times 4, sorry for all the brackets, and then all of that times by I. Then we have the middle, let's change the colour of this. Then we have the middle term, which can be, so first we use this, we use J, then we do this block matrix of the whole thing, but just ignore these two here. So now we have 5, 2, 3 and -4 as our matrix. This will then give us 5 times -4 minus 2 times 3, all multiplied by the unit vector j. Then finally we have plus, going to go back to, then finally we have plus, and we do our k, which will be, actually I'll do this in black. So then we have our k, which will be this bottom left one. Hopefully it doesn't get too messy. And you can sort of see, I'll do a bit thicker. Like that. And we're no longer ignoring this 3 and the 4. So we'll do the determinant of this block matrix, which is 5 times 4 minus 3 times 3. All of that times by the unit vector j. Now, we do the individual calculations. We've got minus 12 from the first one, minus 8 from the second one here, times by I. Then we've got minus 20, minus 6, times by j. Then we have plus 20, minus 9, times by k. Oh my gosh, I've gone a bit downhill here. Then finally we have minus 20i, minus a minus, so that'll be plus 26j, and then here we have plus 11k, and that is our v cross w. Now hopefully this video has either refreshed your memory or you've learned something new from it, as we've discovered what the dot product and cross product are and how to apply them in different sorts of questions and scenarios.